Good day, engineers. We are going to conduct and present an existing virtual laboratory simulation entitled Redwood Viscometer Experiment as our final project in ME 415 ME Laboratory 1 that falls under the properties of fluids and lubricants. To start with the presentation, I will discuss the theories and concepts of the project. Viscosity is a fluid flow property and is one of the most important properties of a lubricating oil. It is defined as the measure of fluid's resistance to flow, or what we call the internal friction to shearing stresses. We have two main types of viscosity, the dynamic or absolute viscosity and the kinematic viscosity. The former measures the ratio of the shear stress to the shear rate of fluid, while the latter measures the ratio of the dynamic viscosity to the density. And by Newton's law of viscosity, the shear stress between adjacent fluid layers is proportional to the velocity gradient between the two layers. Thus, a proportionality constant of the coefficient of dynamic viscosity is introduced. The formation of a fluid film of a lubricant between the moving friction surface and the generation of the frictional heat under the particular condition of load, bearing speed, and lubrication supply mainly depends upon the viscosity of the lubricant or to some extent to its oiliness. If the viscosity of the oil is too low, the fluid lubricant film cannot be maintained between the moving surfaces, as a result of which excessive wear may take place. And on the other hand, if the viscosity of the oil is too high, excessive friction due to the shearing of oil itself would result. Hence, in hydrodynamic lubrication, the lubricant should possess the proper viscosity, so it is of vital importance to have knowledge of viscosity of the lubricating oil. Viscosity of the fluid may be measured in several ways, and one of which is by determining the time required for a definite amount of the liquid to flow through a capillary. Such method includes the use of Redwood viscometers.
The objectives for the Redwood Viscometer experiment are: first is to determine the viscosity of engine oil and glycerol. The second one is to familiarize oneself in the procedures required in operating the Redwood Viscometer. The third one is to establish the relationship between temperature and viscosity of fluids, and to identify which fluid would be more ideal for lubrication application.
So for the materials of the Redwood viscometer experiment, we will need a Redwood viscometer, 50 cc volumetric flask, stopwatch, engine oil, glycerol, and thermometer. For the parts of the Redwood viscometer, here is a diagram of a Redwood viscometer. We have thermometers, water ball valve, oil, and the liquid to be tested. There is a constant temperature bath because we will be changing the temperature of the fluid to be tested to establish the relationship between the temperature and the viscosity of the fluid.
So now let us proceed to the virtual simulation. To start off, the first thing we are going to do is to select the fluid and set the temperature for each trial. Moving on, for the first trial, we will use engine oil as the fluid and set the temperature to 55 degrees Celsius. And after that, we are going to click the lift button in order to allow the fluid to flow into the volumetric flask. Now, we will just wait and observe the rise of the fluid until it reaches the 50 cc mark, which is, as you can see, the red line on the upper part of the flask. Then, after that, we will record the time it took for the fluid to reach the red mark. So, the time we have now is 525 seconds, and consequently, the value of the kinematic viscosity will be displayed automatically. So our calculated value of the viscosity is 1.29 centistokes at 55 degrees Celsius. Now, we are done with the first trial, and what we need to do is to repeat the same procedure for the succeeding trials and increase the temperature by 5 degrees Celsius after each trial for the same fluid. So for the second trial, we recorded the time of 325 seconds, and the value of the viscosity is found to be 0.80 centistokes at 60 degrees Celsius. So for the third trial, the time recorded is 250 seconds, and the value of the viscosity is 0.61 centistokes. So as you can see on our recorded time is 135 seconds, and the viscosity is 0.32 centistokes at 70 degrees Celsius. And for the last trial, the time we got is 85 seconds and 0.20 centistokes at 75 degrees Celsius.
So to start again the simulation process, we need to click on the drop-down list and select the fluid that we prefer to test. In this case, we are going to select glycerol. Next step is to select the temperature, which is 55 degrees Celsius. And after selecting the fluid temperature, we are going to click the lift button. Then the fluid will begin to flow. Observe the rise of the fluid in the container and click the stop button when it reaches the 50 cubic centimeter mark. We need to be careful not to overflow the container or else a prompt will appear. As for the first trial, we got a time recorded value of 468 seconds and a viscosity at 1.15 centistokes. After that, we are going to click the reset button to reset the setup from the start. Then select the next temperature and perform the procedure for all remaining temperature with a 5 degrees Celsius increment. For the second trial, we got a time recorded value of 330 seconds and a viscosity of 0.81 centistokes. For the next trial, for the third trial, we got a time recorded value of 235 seconds and a viscosity of 0.57 centistokes. For the fourth trial, we got a time recorded value of 118 seconds and a viscosity at 0.28 centistokes. Lastly, for the fifth trial, we got a time recorded value of 81 seconds and a viscosity of 0.18 centistokes. And that's all for the procedure.
We can see in the engine oil, the lowest temperature has a higher viscosity. And for the highest temperature has a lowest viscosity. Also, the same in glycerol, the lowest temperature has the highest viscosity and the highest temperature has the lowest viscosity. Um, it was shown in the graph the comparison of both engine oil and the glycerol. Therefore, we can conclude that the lowest temperature has a highest viscosity and the highest temperature has lower viscosity. That's all. Thank you.